This is the basic structure of a voltaic cell. It consists of two half cells. Each half cell contains a block of metal as well as a metal salt solution. In this particular case, I'm using copper and silver electrodes. So this half cell consists of a copper electrode, which is a block of copper metal, within a solution of copper sulfate. And in the aqueous form, we can see that copper sulfate is already dissociated into its constituent ions, that is Cu2 plus and SO42 minus. Now looking at the other half cell, we see a block of silver metal, so that is the silver electrode, and this is placed in a solution of silver nitrate, so that is already dissociated into its ions, so Ag1 plus and NO31 minus. Now there is also a salt bridge that is connecting these two half cells, and I will deal with what this salt bridge does a bit later. This salt bridge consists of an NaCl solution, and it is plugged by cotton plugs to prevent the solution from pouring into the cell. Now, when I connect these two electrodes by a conducting wire, a current will begin flowing through the cell. A bulb glows. So that means there is a current flowing through this conducting wire, and there are electrons moving through this conducting wire. So that must mean that electrons are either moving from copper to silver or silver to copper. When we look at the reactivity series for metals, we see that copper is higher on the reactivity series as compared to silver. While copper is not a very reactive metal, in this case, it is more reactive than silver. So it has a greater tendency to lose electrons and form ions as compared to silver. And when silver is compared to copper, silver ions have a greater tendency to accept electrons and form silver metal. So in this case, this is what happens. Since copper is higher on the reactivity series as compared to silver, in this reaction, copper will get oxidized and silver will get reduced. So the copper loses electrons to form copper ions. These electrons move along the conducting wire to silver, and the silver ions in the solution accept these electrons to form silver metal. I will now take you through this process. To demonstrate what happens, I have shown this copper atom contained within this block of copper metal. Now, this copper atom, all the atoms in this copper block of metal, will get oxidized, as in they will lose 2 electrons to form a copper 2 plus ion. Now, that copper atom will be oxidized to form Cu2 plus, which enters into this solution here, as well as 2 electrons. Now, these electrons will take the path of least resistance along this conducting wire. So these electrons travel along this conducting wire, the path of least resistance, the silver block. Now these electrons will enter this silver block, and since these Ag ions are extremely attracted to these electrons, the Ag ions will flow towards the silver block. Each silver ion accepts 1 electron to form a neutral silver atom, and thus they form silver atoms that attach themselves to this block of silver metal. And so we can see that the copper atoms will lose their mass, forming ions which will release into solution, and then an extremely small part of their mass will form electrons which are going across this connecting rod into the silver. And the ions from the silver nitrate solution will be forming silver atoms and becoming a part of this block. So we can see that copper will continuously begin to lose its mass, and this block of copper metal will actually decrease in size, while the block of silver metal will be gaining atoms of silver, which will increase its size. Now this process happens continuously. Copper atoms break up, they oxidize to form copper ions and 2 electrons. These 2 electrons travel across, attract silver ions to form silver metal. And this is what causes a flow of electrons through this conducting rod, which ends up making a bulb or any appliance turn on, causing a flow of electric current. And this happens until the copper metal is used up. All the atoms of copper have been turned into copper ions and moved into the solution. Now, since oxidation takes place in this half cell, the copper metal is losing electrons to form copper ions. This is the anode. And since the opposite happens here, reduction takes place here, the silver ions in the solution are gaining electrons, so that's reduction to form silver metal. This is the cathode. Now, as the reaction keeps running, there results in an increase in copper 2 plus ions in this half cell and a decrease in Ag plus ions in this half cell. So there is an increase in the positive charge. There's an overwhelming amount of positive charge compared to negative charge in the solution here. And there is a much less percentage or concentration of positive charge as compared to negative charge here. So negative charge overpowers positive charge here. And this is the reason a salt bridge is used. This buildup of charge in these cells can prevent the proper running of this voltaic cell. And the salt bridge serves to neutralize this charge. When there is a buildup of positive charge here, the negative ions from the salt bridge, that is the Cl minus ions, start flowing into solution. They pass this cotton plug and they flow into the solution to neutralize this solution, make it less polarized, make it less charged. And here, since there's less positive charge, overwhelming negative charge, the positive charge, that is the sodium ions, flow into solution to neutralize it. So as you can see here, the positive sodium ions are flowing into solution here, and the negative chloride ions are flowing into solution here. That helps to keep the voltaic cell running smoothly. Now, to sum this voltaic cell up, since copper is high on the reactivity series, it gets oxidized, it loses electrons to form copper ions. These electrons move across this conducting wire to the silver block. The silver ions within this solution accept these electrons to form silver metal, attach themselves onto this silver block. This is a voltaic cell, and since oxidation happens in this cell, reduction happens in this cell, we can see that there is a redox process taking place, which will have two half reactions, which are as follows. So the two half reactions for the one for the anode, that is the oxidation half reaction, is copper loses 2 electrons to form copper 2 plus. So copper gives copper 2 plus and 2 electrons. And silver 1 plus accepts 1 electron to form silver metal. And since 2 electrons are being lost from here, to conserve these 2 electrons, I am balancing it out to form 2 silver 1 plus ions, except 2 electrons, except 1 electron each, so they in total accept 2 electrons to form silver metal. So the net redox reaction that is taking place is this. Cu plus 2Ag plus gives Cu2 plus 2Ag, which means that we start off with copper and silver ions and we end up with copper ions and silver. This is the net redox reaction that is taking place, which shows the transfer of electrons from copper to silver across the conducting wire, which provides an electric current, which is what these voltaic cells are used for. This is the shorthand form of drawing this voltaic cell, where the two electrodes, copper and silver, are on the ends. The solutions, that is what is contained, what primary active ions, as in ions that are taking part in the reaction, are in the middle, and the two lines here represent the salt bridge. So this is oxidized to form Cu2 plus, electrons flow, here's the salt bridge, and 2Ag plus, a reduction takes place, as in 2Ag plus gains electrons to form 2Ag.